Okay, so we're going to talk a little bit about economics and the environment. It's important to understand when you're looking at economics that it's not just about money, but it's also about resources. So when we take in raw materials, we put them through a process. Through the production process, we give products, whether that's lumber or whatever product the society might need. We consume that. There's money that drives the whole process, and then we put it out as waste. So both our sources and our waste sinks are considered kind of a resource when you look at the economics in terms of the environment. So when you have national income accounts, when you are looking at economics of a particular country or nation, you have gross domestic product and you have net domestic product. So gross is the baseline, so that would be like your annual salary or your hourly salary. And your net is typically, after everything is taken out, all of the charges. So for the salary, what you take home would be your net after taxes and things like that. So here's how we would calculate it in terms of the environment. Our national domestic or net domestic product is going to be our gross domestic product, take away depreciation and capital expenses. You do not need to calculate this, you just need to understand the concepts behind it. Consuming non-renewable natural resources is usually not accounted for when economists are looking at a particular nation. And a lot of times degradation of natural resources from pollution is also not accounted for. So the cost of cleaning up our waste and the cost of using our natural resources is typically not accounted for in terms of the national income accounts. So those external costs that are rarely considered may actually be costing us more than we think. Whenever we do an ecological risk assessment, the EPA has guidelines for estimating the probable effect of human activities in an ecosystem, from stressors, which are human-induced changes, things that affect the environment or tax the environment, and then we have to do a cost-benefit analysis, which is the estimated cost compared to determine how much expense we will incur if we take something from the environment, if we derive some kind of environmental benefit. We have to analyze, is the cost and the benefit going to work together, or is it going to cost us too much for what we need, or is it actually a really good, efficient benefit because it doesn't cost a lot at all? So there's an analysis process there. When you do the risk assessment, the estimation of risks for comparative purposes, it's going to help us to set priorities and manage those risks. So similar to, let's say, an insurance company determining your monthly rate for insurance, they look at the risk for covering you. If risk is certain, the probability is 1. If risk is certain to not happen, the probability is 0. So the closer you get to a probability of 1, the higher your insurance rate would be. In the case of the environment, when we do a risk assessment, we have to look at the probability of certain events taking place or certain risk being put onto the environment. And then we have to manage that. So we have to determine the need to reduce or eliminate that particular risk. So that includes our cost-benefit analysis, and it also includes our ecological risk assessment. We have to look at every action we take, how will that affect the environment? And is it worth the benefit? Does the cost-benefit analysis give us a positive effect, or is it too much of a risk on the environment? We also look at toxicology, so we study the chemicals that have adverse effects on our health. The dose is the amount of the toxin that enters the body. So if there is some kind of pollution that is in the environment, let's say it's in the waterways, we need to look at how much of that toxic substance is going to enter the body or enter, fish, marine animals, things like that. The response is what type of damage is caused by exposure to that dose. So there's a lethal dose, which is just how it sounds, and then there's an effective dose, which means that over 50% of the population will exhibit whatever the response is. So if it's a toxic substance that causes rashes on the body, then the effective dose would be however much it takes for 50% of the population to exhibit the rash on the body. The lethal dose is how much it is lethal to the dose that is lethal to 50% of the animals. So the lower the toxic dose, the more toxic it actually is. The less it takes to reach 50%, the more toxic it actually is. We look at carcinogens. When we look at toxicology, there are a lot of pollution substances throughout our environment that are cancer-causing substances. Table 2-1 in your text will also give you more information on that. So a prime example of this would be cigarette smoke. It is a carcinogen. It is known to cause cancer. It's also known to cause heart disease, lung disease, other different diseases, stroke, not just lung cancer, but also other kinds of cancer, from esophagus cancer to mouth cancer, all kinds of things. So anything that's a carcinogen is extremely toxic. And unfortunately, we don't know that it causes cancer a lot of times because it's internal. So it's kind of hard to track that. So whenever we do an ecological risk assessment, we have to assess the impact of environmental damage in the different areas of the environment, like our water, land, air, plants, and animals, and how they interact with each other. So if you damage the water, how does that affect the plants and animals? If you damage the air, how does that affect the plants and animals? So there are interactions from that impact. So going back to Lake Washington, sometimes the environment, the damage to the environment can be reversed. Sometimes it just takes a little bit of work on our part. So, for instance, in Lake Washington, the problem they had was raw sewage being put into the lake, which made it nutrient-rich, which was good for plants, but it was also eutrophic, which was bad for the animals. So we had to do a risk analysis. We had to identify that problem and then analyze the environmental, social, and political risk involved. There was a little public education involved as well. They had to let the people around the area know, let their neighbors know what was going on and how they could help. Then there was some political action that had to come into play, and then finally there was follow-through and remediation. So if you do the first 4 steps and you don't do the follow-through, then it was all for nothing. So here's a picture of Lake Washington, so you can see they wanted to put that raw sewage initially, they wanted to just dump it into the Puget Sound, but that was deemed to be too much of a risk for the rest of the environment. As you can see, Lake Washington is just a small part of water attached to the Puget Sound, and so that was a huge issue. This is a picture of what it looked like, so you could see some of the pollution effects there. And so attached to the Puget Sound, which over to the top right hand of the picture is a nice looking body of water, but Lake Washington itself was nasty, just nasty. Okay, so back to what we started with. Sources that are a part of the environment from which the materials move, those are our raw materials, and we depend on natural capital to provide those sources, those raw materials. And then we put them into production, we create the products that our economy needs, we consume them. Of course, that creates waste, which is part of the environment that receives the input of the material. Okay, and so when we look at economics, we have to study how people use their limited resources, and it also depends on that natural capital to provide the sources for raw material and sinks for waste products.